Hi, in this video, you're going to learn how to use the TI83 or 84 calculator to graph parabolas, and we'll use that as an example of the types of functions you can graph while controlling the graph window and getting information from the graph, as well as tables of values. I've listed the topics to be covered over on the left side, and we're going to work through them in that order. Get your calculator, turn it on, and push the y equals button, and this is where we enter functions. It's set up for functions because it has a y output based on a rule using x for an input. So first up, implied multiplication automatically happens. So if we had something like 3x, I don't need to put the multiplication symbol in. 3x is recognized by the calculator as 3 times x. So we don't need to worry about multiplication in those sort of situations. Also, notice that I'm just going to clear this. Notice that the X button, the one that says xt theta n, that's the button we're going to use for inputs. So we're going to start with x squared. So I'm going to use the X button and then the square button. And I'm going to graph that. It's possible to graph more than one graph. If I just go down arrow, I'm at y2, and this would represent another function. Notice that the equal sign is black. That means it's turned on. The second graph I'm going to enter is negative, which, by the way, is different than subtract, and you'll get an error if you misuse those in different places. I want a signed negative, x minus 1, now notice how I use the minus that time, squared plus 1. So this is also a parabola, and if you've studied parabolas a bit, you'll know a little bit about what the minus 1 and the plus 1 and the minus sign are doing. If not, don't worry about it too much right now. I'd like to graph both of these functions, so you notice that the equal signs are both on. Now, I'm going to move into option 2 here, or topic 2 rather, window. There are some pre-configured choices to know about. The zoom button here controls different ways of seeing the graphs. Zoom 4 is called zoom decimal. And if I choose zoom 4, I will get a graph image centered at the origin, and it's configured for the pixels of the calculator. You'll notice that the calculator is wider than tall. There are more pixels horizontally than vertically. And if you push the window button, you'll see that the x min and max, representing the far left and far right, spans 9.4 units total, while the y min y max spans 6.2 units in total. These are strange numbers, but they are a ratio that takes into account how many vertical pixels compared to how many horizontal pictures. So zoom 4 will give nice graphic images for functions that are right near the origin. And so often you'll want to choose zoom 4. Zoom 6 is another pre-configured option. Notice that you can go down arrow or type the number. This time I'm going to go down arrow to show you how I can select that way. So I went too far. This is one of the reasons I don't like to do it that way. I'm now on 6. I push enter. I'm going to see the same two functions, but under a different window. And you'll notice that they look a little bit different. Go to window, and we'll see what zoom 6 is defined as. Plus or minus 10, plus or minus 10. Now, that's really nice if we were graphing things manually on graph paper where the scale is the same on a piece of paper horizontally, vertically. But when it comes to a graphing calculator like this, again, notice there's more pixels horizontally than vertically. So it can distort the image. In this case, it's not particularly important, but in some cases it will matter. I also don't like zoom 6 very much because you'll notice that the actions seem to be happening near the origin and we can't see it as well. I'm going to show you another zoom option, zoom 0. What zoom 0 does is it will give the range values or y values for your given x or domain values. So let's go to the window, and suppose we already know some things about those functions because we already saw them. Maybe I only want to go from -3 to +3 for x, my domain that I'm controlling, also called the independent. Now I'm not too sure how low and how high to go. Zoom 0, I'm going to scroll down and find it. Zoom 0 is a zoom fit window. It will fit the y values for your x values. So let's choose that and see what it looks like. Now you'll notice we get quite a different looking image again. So window is very important to think about for the visual output you're going to get and to try to effectively see the graphs you want. You're going to need to experiment with this a little bit and learn some more about it. Notice that my domain, 1 unit, see the ticks along the x-axis are quite wide, while my vertical, the ticks, are very close together, representing a very large range. Let's go to Window, and you'll notice that my -3 to 3 corresponds with y values from -15 to 9, so a span of 6 horizontally, but 24 vertically. There are other zoom options, and you may want to experiment with some of those yourself. Zoom box is kind of interesting. You get to establish a box around part of a function, and then it will regraph just the box. Zoom in and zoom out are pretty standard to understand. You can experiment with those. I'm going to go back to Zoom 4. Okay. Now, I could also choose User Configured. You can always click the Window button and choose whatever X's and Y's that you want to try to override the controls and get the image just the way that you want. Now, point 3 about Graph View. So you'll notice above the Zoom button there's a Format option. And we select Second Function, Zoom, to get the Format menu. And there are a number of formatting choices to have. I would recommend that you have your calculator set with all of the left options enabled, and you'll know they're enabled because they're black. The one thing you may want to consider changing is Grid, and turn Grid, oh, I went too far, turn Grid on. Let me show you what that looks like. You'll get these dots, or lattice points. So for example, this point right here, where my pointer is pointing, has an x value of 1 and a y value of -1. Right here is on the y-axis, 0, -1. And if we had to estimate where these graphs are crossing, it looks like x1, y1. So grid is kind of handy, and the grid control really comes through Window, Scale. You'll notice I didn't mention scale before. I'm going to change the x scale to 2. I'm going to change the y scale also to 2. Watch what happens to the grid. We get far fewer points because now they're counting every 2 units, 4 units, 2 units, 4 units, and so on. So if I were to change my window and make this decimal 2, for example, oops, I think I changed the wrong thing. Always got to be careful about where you enter things. Let me fix that. Decimal 2, there we go. And let me show you the grid now. That's a bit overwhelming because it's counting every decimal 2 and making a dot. Sometimes you'll want to turn the grid off. Let me go back and just turn grid off. Okay, excuse me. Next, Calc Tools. So once you've got your graph, and I'm going to go back. Yeah, this is okay. This is Zoom 4. And you want to know some things about your graph. Choose Second Function, Calc, and there are a number of choices. You can choose to find out a value of a function. Okay, let's try that by pushing Enter. I have an input here and it says x equals blank. Let's say x equals 2. So it's going to tell me the value of the y portion of the function for the function y1. You'll notice up in the left it's defining which function. Now, if I go down, you'll see that it's now telling me about y2, and it's giving me the y value. And you'll notice the cursor's flashing there. The cursor wasn't flashing previously because I was out of scale up here past the view window. So again, an issue with choosing your view window. I can calculate the 0. The 0 is the same thing as the x-intercept. Now you're going to be asked for 3 things. A left boundary. Let's say I'm trying to find this 0 right here. I'll need to tell the calculator a coordinate somewhere on the graph to the left. I'll use my cursor to move along. Oops, I got to go to the right by the look of it. There I am. Oh, by the way, I noticed I'm on y1. I'm going to go down arrow to get to y2. There. Now my cursor is to the left of this 0. I push Enter. Next, it asks for a right boundary. I've got to move the cursor somewhere to the right of this point. So I'll click along here to the right. Now, I'm going to show you another thing. You can click many times, or you can actually type in a number. I'm going to type in the number 3 for x and enter. Now you notice that these little arrows here are telling me that the calculator has been told to look for a 0 between these values, which is what I'm looking for right in here. That's good. Third thing I'm asked for is a guess value. Move the cursor somewhere in that area and push enter. You don't have to be close. There's the 0, or the x-intercept. When x is 2, y is 0. You can also find minimum or maximum points, which for a parabola are the vertex values. An intersect value, meaning where two graphs cross each other. 6 and 7 have to do with calculus, so we won't be using them until you do calculus. The options for 3 and 4 are very similar to 2. You need to choose a left and a right boundary in order to figure out the minimum or the maximum. Let's try option 3 for a minimum. So y1 has a minimum at the origin. I'm asked for a left boundary. I'm going to type -1, a right boundary. I'm going to type +1. A guess value. Now again, notice that the arrows are representing the range that has the 0 in it. A guess value, let's move my cursor a bit closer, and the 0 is this strange number. Now this is the calculator being silly. This is 5.09 times 10 to the -7, scientific notation, and 2.59 times 10 to the -13. This is the calculator's way of saying 0. Basically, this is a rounding error internally in the calculator's algorithm, and this is an extremely small number and an extremely small number. It's representing 0. I'm going to stop the video at this point, and I'll take up the other values and a few more things in the second part of this topic.